Hello, everyone, and welcome to the 15th webinar in Joint Transit webinar series, which will cover different projects related to improving safety and reliability of rails from three quite different perspectives. Today, we're privileged to have 4 transportation experts presenting in this webinar. We will have 3 15 to 20 minutes presentations. First, Dr. Samir Ahmed will discuss safety of vulnerable road users in light rail transit environment. After that, Dr. Tara Tolford and Dr. Wang Tian will present on the evaluation of New Orleans and Baton Rouge rail terminals and transit links. Finally, Dr. Eric Dunbar will provide comprehensive overview over the traffic safety effects of introducing transit service on urban freight corridors, an examination of Orlando Sunrail and Charlotte links. We will save questions until the end of the 3 presentations for a 15-minute group questions and answers. You can type your questions anytime throughout the session. Without further ado, I will introduce our first speaker, Dr. Samir Ahmed. Dr. Ahmed's technical interests include design, planning, operation, and management of transportation facilities, intelligent transportation system, transportation safety, and transportation policy. He has been involved in several research projects sponsored by Federal Highway Administration, the Federal Transit Administration, the Oklahoma Department of Transportation, and the transportation industry, totaling more than $18 million. His recent research projects include transit safety management and performance measurement, pedestrian safety in light rail transit environments, quality assurance in highway construction, and the National Motorcycle Crash Causation Study. Dr. Ahmed, I will turn it over to you now.
Thank you. Thanks, Daniel. So now I need to share my screen, correct?
Yes.
Well, I had my screen shared already, so
yeah. You have to reshare.
Okay, I'll stop sharing and do it again.
Yeah.
Okay.
Please. Yes, please.
All right. Can you all see? Everybody can see this first slide that has the title of the presentation.
Yes, we can see it.
Okay, thank you. Again, my name is Samir Ahmed. I've been introduced. There's a co-PI, Dr. Balut, is here also at Oklahoma State University. Okay, the agenda for this webinar briefly, or before I start that, I have over 60 slides. I'm allowed 15 to 20 minutes, so there is no way I'll show 60 slides. So I'll be giving about maybe close to 20 slides presentation. They don't show all the details needed, but if there is any interest in more detail, I'll be happy to show it. It will be included, but at the end. First, we'll go to background about the problem and the motivation for doing the work, and then the research plan, which was submitted to Tran-SET, the behavior of vulnerable road users who are VRUs and their behavior, available safety treatments for VRUs in the light rail transit environment. There are 3 types of treatments, categories: engineering, they call it physical, there's education, and there is enforcement. And questions and answer at the end. For those who don't know what light rail is all about, LRT includes modern streetcars and trolleys, and it's one of the fastest growing modes of public transportation in the United States. These are examples of what we call LRT systems, modern systems modern systems, and these are heritage systems. We call them streetcars. This here shows the increase or the growth in the number of LRT systems in the US between 1988 and 2018. And the source of this information comes from American Public Transit Association, their 2020 yearbook. As you can tell, the blue bars, which show the light rail and streetcar, just has been steadily increasing at a faster rate than the commuter rail or the heavy rail. Light rail transit systems, the majority of them, they are fitted to the existing corridors, urban corridors or suburban corridors. By a corridor, I mean the right-of-way, say a street, okay, or a highway. So you take part of that roadway and allocate it for the light rail, okay? So that makes it very easy then to introduce light rail. That's why they are very popular. You don't have to construct a new rights-of-way. A slight modification of existing rights-of-way. The disadvantage of that is that right-of-way will be shared in most of the time. Okay, I mean more conflicts between the light rail vehicle, pedestrians, and other automobiles. You can have light rail in a semi-exclusive right-of-way, like say barriers that separate the right-of-way for light rail from other users. But the majority are in shared right-of-way. The term VRUs, or vulnerable road users, it refers to those most at risk in road traffic. Typically, pedestrians, cyclists, and electrical scooter riders. Of course, there are motorcycles as well. All of those are unprotected by an outside shield. Like if you are in your car, there's an outside shield there, the body of the car that protects the passengers and the driver. VRUs, they don't have type of protection. In 2009, the World Health Organization reported that half of the 1.2 million transportation-related fatalities occurring each year concern vulnerable road users. VRUs are heterogeneous groups. We don't have one group who call it VRUs. There are several groups that fit into what we call VRUs, okay? And these groups differ in their characteristics, travel habits, and the behavioral patterns. Among all VRU groups, the elderly, the disabled, and the children are more vulnerable than others because they display certain amount of task incapability. For example, elderly, walking speed is low, like same thing for children. Elderly, they can't move their head right and left easily, okay? Children, they are not aware of the risks involved, so they can make risky behaviors or actions. Disabled, of course, it's clear that they can't move fast, that they have to utilize certain devices in order to be able to navigate. The motivation of this work is that operating light rail vehicles, which we are going to call it LRV, LRT is light rail transit. LRV will be light rail vehicle. Operating light rail vehicles along shared or semi-exclusive rights-of-way introduces conflicts and increases the risk of collisions with vulnerable road users. These here are examples of, say here, just trespassing on the right-of-way for the light rail. Again here, crossing the right-of-way without looking carefully left and right. Running to catch a train here, okay? I'm going to talk about this changeable message sign. This here tells the pedestrian that there is a car coming from the right. As you can see here, that icon there. So, but still, if somebody is running, they probably are not paying attention to that sign and they can't tell whether that train is moving or is stopped. Reducing collisions with vulnerable road users has been identified by FTA as the second item of their top 10 safety action items for improving rail transit safety. To develop effective safety treatments for VRUs, we have to understand the behavior of pedestrians, cyclists, scooter riders along LRT alignments. The project involved survey or evaluating existing body of knowledge, synthesis of this information and putting it on what we call best practices resource guide and an accompanying PowerPoint training material. These materials will be used by light rail agencies. Okay, they can use it, say, in fairs, in schools, presentations at stations. Just this information here, they can use it to educate and make the public aware of the risks that exist in light rail environments. They can also be used to train new employees coming to join the workforce in light rail. There were 8 tasks. All those tasks have been already accomplished. Right now, I am in the implementation phase, which is task 8. The body of knowledge involved a number of existing TCRP reports. They are listed here. Integration of light rail into city streets, light rail service, pedestrian and vehicular safety, audible signals for pedestrian safety and light rail transit environments. These are just examples, and there are more of that, of course. These are the common safety problems that have been mentioned in every one of those 3 TCRP reports. The National Transit Database also has their own list of issues that are included in the NETD. For Report 17, TCRP 17, trespassing, jaywalking, station and/or cross-street access. Report 69, they list limited sight distance at pedestrian crossings because of walls, devices, etc. And the pedestrians darting across the tracks without looking. Report 137, which had to do with audible devices, they talk about inattention, confusion about the meaning of control devices, lack of appropriate physical separation between vulnerable road users and the light rail vehicle, risky behavior by pedestrians, there's just lack of respect for controls, and operator error sometimes, or lack of information to the operator of the light rail vehicle. The NETD mentions rushing to catch trains, which has been listed with and others, ignoring audible and visual warning devices, distractions, not paying attention at transit malls, intoxication, and trespassing. Of course, there is also the issue of suicides, but we don't include that here in the discussion. That's a completely separate topic where people intentionally use the rail system to kill themselves. Notable behavior issues for VRUs include most pedestrians take the shortest paths between where they are and where they want to go. They don't care about just having market things and the gates, etc. So when you make these pathways, when you design it as an engineer or planner, you have to pay attention that you follow the shortest path. Otherwise, whatever you will put there, it will not going to be used by pedestrians. LRT grade crossing facilities should be located at the most direct crossing locations. That's the first principle. Pedestrians are concerned about reaching the station before the train arrives and leaves. Therefore, they run. If they are late, they run. And of course, they are not looking at where is the train, and they don't understand the risk involved. Pedestrians have minimal understanding and evaluation of the threat of law enforcement. Many pedestrians have a sense that they control the right-of-way, and everybody else got to wait for them. Many pedestrians trespass into the right-of-way by jaywalking or crossing at locations that don't have appropriate crossing facilities. Pedestrians step into the LRT right-of-way to get around the people waiting at the station to avoid crowds. Pedestrians ignore warning devices such as flashing lights and bells. Pedestrians tend to look down, they don't look up. So if you are posting a sign or something that's up, they need to raise their head. Most likely they are not looking at it. Pedestrians cross the tracks after a train had left. If you have train approaching from right, another one approaching from left, after the train from right leaves, pedestrians are not aware that there's another one coming from left. So again, the issue of second train coming is a major problem. Pedestrians are inattentive and not always alert to their surroundings. Again, the gadgets that we all use, just distractions. Pedestrians don't stop or slow down before entering a crossing. Pedestrians fail to look both ways at the crossing location. They stand too close to the tracks, so they occupy part of what we call the dynamic envelope. That should have been reserved only for the light rail vehicle. Pedestrians and bicyclists routinely cross LRT tracks behind automatic gates. So although the gates are down, still they still attempt to cross. The treatments available from the published survey of the published literature and other transit agencies, their safety folks. Available treatments include what we call engineering, sometimes referred to as physical treatments, education programs, either designed by national organizations like Operations Lifesaver or by individual transit agencies. So that's the education part. And finally, we have enforcement. The engineering treatments, and again here I'm going to show a list, but if you need details and the pictures and discussion, I reserve that to later on if there is a need. Physical treatments can be either passive or active. Passive treatments are static. They don't change whether there is a train or there is no train, the same message, okay? Active physical treatments, they are dynamic. So the message itself can change, okay, to alert users about the approaching light rail vehicle. Examples of passive treatments include static signs, like say railway crossing signs, pavement markings that delineate the dynamic envelope. So these are static or passive type of treatments. Active treatments include what we call light rail vehicle activated. The approaching light rail vehicle will activate the active treatment. Okay. Examples include train coming type of icons, pedestrian auditory icons, and automatic pedestrian gates. Taken as a whole, active treatments, as we expect, are more effective than passive ones. The change that occurs in an active device has the effect of generating attention. This can increase the effectiveness of the basic message. Types of physical treatments include, as we said, passive signs, signals, and active warnings. Active warnings include active signs. Second, train approaching treatments. Pedestrian gates. Some gates are lowered, some gates close, and you have to push the gate to enter. So that will force you to stop when you are attempting to open the gate, so you can look left and right. Channelization, making sure that when the person is crossing the light rail crossing, they are going to be walking facing an oncoming train so they can see it. So the objective of channelization is to ensure that the vulnerable road user will see an approaching train. Pavement markings, some of them are static, some of them are dynamic, like say those flashing lights and pavement marking. Illumination, making sure that the intersection is illuminated by external light. Of course, intrusion detection systems to detect if somebody is walking or somebody is attempting suicide, but these are not very, very common, the intrusion detection systems. Again, if somebody is interested in any of those, I have about close to 30 slides or more that show details of that. The second category of treatments involve education, and the third one involves law enforcement. Education programs. We're going to talk briefly about types of education programs. As I said, there are national programs and there are in-house programs designed by the Light Rail Agency. Who are the target audience for education programs? Educational materials available, preparing the presenter and training them, public education venues for conducting the education, and evaluating the education programs to see their effectiveness or any improvement that can be made.
Dr. Ahmed, I'm sorry,
Yes, sir.
just due to time constraints, we need to start wrapping up the presentation. Okay.
Absolutely. Thank you for telling me. Education programs, ongoing grade crossing public education programs. They are used at new start systems. New starts refer to new transit systems that are just starting at a city where they never had transit. And there are programs, education programs, that focus on trespassing and suicide. Target audience include people who live, work, or go to school close to the light rail tracks, high-risk locations and the corridors based on crash histories, and then non-residents like tourists and the business people who visit the city, so you can have some literature in hotels and conference places to tell them about the risks of light rail. Operation Lifesaver is a national organization. We have designed the material that's on loan to any agency. The material is flexible, so it can be fitted to individual agencies. Scalable, the time span, it can be an hour, can be 15 minutes, and it can be in English, Spanish, or other languages. The other type of education materials are the transit-specific, agency-specific, or in-house materials. Enforcement involves assigning local police officers or transit police to enforce grade crossing safety. Stations that are marked with patrol cars at randomly selected crossings, and these locations vary every day. Video surveillance of the tracks and issuing audio warnings to people trying to trespass. Posted warnings and signs indicating the amount of fine for those who will violate the controls. I think I should have gone this way. Okay. Because of the difficulties in modifying established behaviors, the largest long-term safety impacts can be gained from education. Okay. Great crossing safety research indicates that education and engineering should come first before enforcement. There are numerous treatments. Which ones to select in a given light rail transit agency? There is here a decision tree in here that one can go through it that will guide the planner or the engineer as to which treatments will work best for that location. The report for this project is about 160 pages. It involves lots of detail. So if you can either read the report or ask me or whatever you like. I'll be available for questions at the end of the other presentations. Thank you.
Perfect. Thank you, Dr. Ahmed. That was very informative and interesting. Now I will introduce the speakers of the second presentation, Ms. Tolford and Dr. Tian. Ms. Tolford holds a, okay, 1 second. Okay. Ms. Tolford holds a master's degree in urban and regional planning from the University of New Orleans, with a dual specialization in transportation planning and land use. She has been involved with the UNO Transportation Institute since 2009 and is currently responsible for leading all bicycle and pedestrian-related programs and research activities with a focus on active transportation policy, data collection, and analysis, as well as international knowledge sharing and outreach projects and development and application of tools in support of smart growth and growth management in Louisiana. Dr. Wang Tian is an assistant professor of transportation studies program and the coordinator of GEE's graduate certificate at the University of New Orleans. His interest and research focus on GEE's urban planning and studies transportation and its social, environmental, and economic impacts. Dr. Tolford, I will turn it over to you now.
Thank you. Let me get my screen shared. All right, so this webinar is on improving safety and reliability of rail. There we go. I would expand that we're not looking directly at the safety and reliability of an existing rail line because what we're talking about doesn't really exist yet. We're talking, however, about the opportunity for that rail as well as the safety and reliability of the connections to and from the proposed passenger rail service that has been considered between New Orleans and Baton Rouge in Louisiana. So the goal of this project was to look at those connections, look at where the proposed and potential rail terminals are in New Orleans, Baton Rouge, and points in between, and figure out how would people get to those if and when this service is developed. And if you've been reading local Louisiana news, there's been a lot of discussion about that in the last 24 hours alone, which I'll come back to as well. So the goal here is how can we optimize the proposed service to connect Louisiana residents to economic centers within the region, given that there is not currently extensive public transit connecting to and from all of these stations. So the goals of this project through Tran-SET were to compile and synthesize all the work that has been done around the proposed rail to date. It's been a little bit dormant in recent years, but it turned out this was really prescient timing to get this project in the pipeline because this conversation is now alive and well again, and we're able to contribute to that dialogue. The goal was to evaluate where the transportation networks are that would connect to the proposed rail stations and to collect data, updated and more nuanced data about who would potentially be riding and what they need in order to make the proposed passenger rail service a success. So that involved figuring out what are the transit and the multimodal priorities, how can we make the rail service really connect to employment and other major destinations, and to start to develop tools for modeling what riders' preferences are, figure out how we can solve some of the gaps in estimating ridership, notably that previous estimates have all just been based on work trips, which is really limiting. And a sort of sub-objective here was that this was such a great opportunity to bring back this dialogue, talk to stakeholders, and get them really thinking about what the next steps are for this proposed plan. flying away here. Okay, so synthesizing what has been done before, we just took a look at all of the previous feasibilities that have been done. We recently completed a state rail plan in Louisiana. There have been a number of station area plans that have been developed, although there's a couple places where there's more work needed there. Looking at how current intercity transit connects this through the region and what the local transit situation is, as well as robust pedestrian and bicycle planning activities that are in the works in some stage of development in several of the communities they would connect, and taking a look at how the previous ridership estimates come up with relative to cost estimates and things. And what we found here overall was that there was a really strong foundation in place to move this idea forward, and it was just kind of waiting for the right moment and opportunity with funding and political will. And we're in that moment, it turns out, with the new infrastructure bill, as well as a merger of Canadian Pacific and Kansas City Southern that own the current freight rail lines within this corridor, who have signaled their willingness to move forward. Our current state and federal administrations now really seems like the time to bring this conversation back to the fore. So to do our part to contribute to this, our data collection was based on a statewide survey, but focused on the Southeast Louisiana region that is impacted. Dr. Tian will talk a little bit more about the specifics of this in a moment, but the general gist of it was we did an online survey that included a discrete choice experiment to start to get at riders' preferences and sensitivities, as well as to some extent understanding how COVID may have impacted things. We had also planned at the time an intercept survey for people who were currently taking the bus in the corridor. We had to cancel that due to COVID as well. And then the goal was to integrate this with spatial data and the built environment to model potential areas of opportunity and things that we want to be aware of. So we did this survey in June and July of 2020, so it's a while ago now. This project has now concluded in the spring, but as I mentioned, it's a great time to still be reviving this conversation. It was based on a conjoint analysis in a platform called Jointly, and we exceeded our expectation in terms of response to the survey with over 4,600 responses, and we were able to geocode over 4,000 of them, which gave us a pretty good, robust sample. However, that was not, as most online surveys are, not a fully representative sample, certainly not a randomized sample. It was heavily weighted toward Baton Rouge, with certain parishes really underrepresented relative to the population. It also, as is very common with online-based surveys, skewed wealthier, whiter, and more of a sort of professional class, people who were employed, even though we were still in the midst of COVID, and a lot of people were unemployed in the region. And we were definitely underrepresenting Black and Hispanic populations, no vehicle households. And so there are some limitations to the data that we were able to collect. We're presenting it here, as you see, unadjusted, just to avoid sort of making false inferences, but that's definitely something to keep in mind. So just to hit a few highlights of the survey results, and the final report is published if anybody wants to dive a little bit deeper into it at any point. Some of the main findings were that this region is already more multimodal than we consider it to be. Even though we have low rates of walking, bicycling, and transit commuting, when we asked people if they commute by multiple modes ever, not like most of the time, like the American Community Survey says, but ever, we actually found that a lot of people do walk, bike, take transit, carpool some of the time. We also found that people in this region travel back and forth a lot. Over a quarter travel, across parishes on a weekly basis or more. Half or more travel regionally at least a few times a month. So there's plenty of activity within this corridor from parish to parish of people commuting or making other trips within the region. We also found out, and this one is definitely an important one for service design for the proposed passenger rail, that the reason people are traveling is mostly not work. Work is important. About half of people, travel for work some of the time, but the much bigger reasons are there's social and recreational and cultural reasons that really drive a lot of activity in this region. And that's, we're talking about Saints and LSU and Mardi Gras and festival season and all the like. We also found that if we're focusing a service design only around 9 to 5 commuters on weekdays and ignoring the weekends, we're missing most of the opportunity here, because that is where so many people are making those trips on the weekends or on both the weekdays and the weekends. We also found, and again, online survey that's opt-in, so we would expect some bias here, that people are really supportive of this proposed rail service. And that goes across geographic lines, socioeconomic lines, everything. And you know, the one area here on this chart that drops lower in the overall support, St. Charles, is the parish that wouldn't have a proposed station in it. So that makes sense. We also found that if you ask people, how should we work on solving I-10 congestion, which is the interstate that goes through this corridor, the overwhelming percentage of them say, build the rail line, much more than expanding bus service or expanding the highways or changing our land use patterns so that people don't have to commute quite so much. Some of our overall findings about multimodal connectivity are that we have some gaps to fill. We definitely are lacking in some areas. Local transit in particular, we found really low perceptions of quality and access. People don't think that transit that serves their local community is that great. In some cases within this corridor, there is none, so that makes sense. Bicycle networks are also limited. We can definitely see that other than a little bit in New Orleans, bicycling is not really seen as a viable option for how they would connect through their community at this point. And the pedestrian environment, walking is maybe the most concerning of all, where in a lot of the region, we found that most people said that walking is very difficult, other than in urban New Orleans itself. It's really hard to walk to anywhere. And that is reflected in how people state that they would expect to get to the stations. Most people overwhelmingly said, yeah, they would drive to the station and take the rail from there. So that's not surprising. We did see that there was the greatest support for multimodal options in New Orleans, where that is currently the easiest. So that is an area where there is opportunity to build. We also found that interest in multimodal travel is growing. We had some questions in there about, what did you do before COVID? What are you doing now during COVID? What do you expect to do after COVID? And we found that there was a notable increase in the amount of people who say they would like to use other options in the future. And also a good number of people who expect that at least some of the time, they're still going to be working from home. So we have to incorporate that into our transportation planning. There are still some concerns about, what happens after COVID, if we can ever even be said to be after COVID at some point. But for the most part, over half are saying they're not really anticipating any changes in how much they would use transit or, consider it. And some even said they're more likely to use transit in the future for whatever reason. And along those lines, most people expect to return basically to whatever their normal was pre-pandemic, with some notable changes like the more active trips, maybe less transit use, and definitely more work from home. Okay, I'll turn it over to Guang for a minute to talk about the more robust piece of modeling that we embedded in this survey to start to get at some quantifiable results.
Right. So for this part, in part of the survey, we have a discrete choice experiment. What we really want to figure out is that, for different configuration of this corridor rail transit, how to maximize the ridership, catch as many people as possible that would use the rail. And so I'm not going to talk details about these methods. It has been used a lot in study people's preferred behaviors, and particularly in this sets with 6 attributes and different levels for each attributes. And in the survey, the respondents gets a pair of choices. They just choose one, which one, over the other. I mean, of course, between the two choices, there are some trade-offs between, like how much it will cost and how long it will take, right? And that's, the balance is try to find what are really the configuration that people prefer if we will ever be built this corridor. And next slide. Tara, can you go?
Trying. It froze on me. There we go.
Yeah, right. So this is how they look like in the survey, there are 10 choices, as I said, and as you can see, like the attributes include mostly like how they get to the station, drive or walk or take transit, and what type of the mode they prefer between New Orleans and Baton Rouge, the train versus bus, and how they would connect to their final destination from after they were in Baton Rouge or New Orleans, right? Where they probably don't have their car at that time, and do they prefer walk or use transit? And also, how long would they prefer to take from their final destination to, to the train, and also the cost of the whole trip, and the different combination of those attributes. And then we used the multi-level large modeling, try to figure out three things, right? We want to figure out among those different configurations of the training, and what are the variants, what are the people's performance, and then second, we want to know, are those performances differ from people to people, meaning their individual characters, whether play a role there, like their age, their income level, or those things. And then the last is the building environment, where, as Tara mentioned, we were able to geocode them, and where people live impact on their performance. So I try to figure out those three things. And next. And so our first model is, to model the attributes to see which one people prefer. And there are a lot of details there. I think we're running out of time. So briefly, people prefer drive to, from their home or their to the station, or from the final station to their destination. And they want a quick travel time. They want lower fares, and those are not surprising. But they strongly prefer train and over bus between those two places. That's very interesting. And also, we found the other one is at their final destination, people are open to take a transit from the station to their final destination. So that's, they gave us the a clue that, as the whole purpose of this study, the connection between those proposed stations and the local communities, that would be, okay to make this whole corridor successful. And next. So next one, we tested whether there are differences among people's individual characters and the building environment variables, and we didn't find too many, but there were three significant variables. One is the income. The people, the income range between 75 to 150K. They not very positive about this whole idea, right? And this is not surprising if you look at the literature, right? The people in this income range, they are not generally interested with, like train or active transportation. They probably more prefer drive their cars. And then the other two are the building environment variables, the employment density and the proportion of employment within half mile of the station transit stop. We see those two variables have increased the people's preference of using the train. So, and this is very encouraging, and it's not surprising. We know that the train in the literature and in practice, you connect the local employment centers and the intercity train and to the local transit network. That's all good things to encourage people to use the intercity train. And the last one, we were trying to use this model to predict ridership as you know, the way we planned it didn't work out for many reasons. But we did able to use a different methods to predict the ridership. Do you want to talk about this, or do you want me to talk about it?
There's some content missing from this slide, but you can give the highlight on what you found here.
Yeah, so so briefly, we use the data we get from the survey and apply that to the population and in this corridor, and also use some transit mode share data from the national survey. We get three estimations: the low estimation, the high estimation, and the average estimation about the potential ridership we got. Even though for the lowest estimation, the ridership could be around 2,800, and that is higher than, I think there were a couple of estimations in the past, and that is also encouraging information with the time going on. People, particularly what we experienced, the regions experienced in the past, the people are more open to multimodal transportation, and for this data showing that sign. And
thanks so much. Yeah, so I think to highlight there is, this is the supply side of, if we had unlimited train service, there's potentially more demand than any of the previous estimates were showing us, because we're looking at more than just those. Oh, that's where the rest of the content was. Yeah, next slide. We're looking at more than just the commute trips, because we found there are so many people who are interested in making other trips by train. So this is what representing a sort of conceptual model of, if we had available, fast, frequent, reliable rail service, what could we capture? And those numbers are, I think, pretty significant. Okay, so just to wrap us up here, the summary findings that we found are that, we have really strong groundwork in much of the region. Since the last feasibility study for this project was done in 2014, the local governments have picked up the ball and been slowly developing their station area plans, figuring out how they would integrate that into their transportation networks. It's been happening, with the minor exception of one of our parishes where they just haven't done that yet. And so this project was able to really revive that conversation and say, let's start thinking about this. The time is now. We know from the survey results that we have a lot of interest in multimodal travel, but that right now people aren't really thinking about that as how they would access the train. They're interested in walking and bicycling, but if they're thinking about, well, how would you go and catch a train to Baton Rouge or to New Orleans, they assume they would just drive there. There is some preliminary indication that COVID has increased a lot of folks' exposure to walking and bicycling while things were shut down. We definitely saw from other research, our trails activity and recreational activity is just off the charts for a period of time. And we know that definitely for higher income workers, more telecommuting is here to stay. So that impacts. We saw really strong support. And we saw some evidence that previous ridership models are making some faulty assumptions here by assuming that commuters are going to be the primary users of this service. And perhaps, at least at first, that's not necessarily the case. We definitely saw these sort of consistent preferences across our neighborhoods and parishes and across demographics, which made it hard to model, but maybe that does make it easier to plan for success if you have a pretty uniform set of preferences in the region. And we definitely note that there is not a lot of support for saying, well, let's just make this a bus. People really, really want the train. But overall conclusion here is, if we want people to get to the train by some way other than driving, which for land use space reasons alone is definitely something that local governments want to see, we really need to start investing in improving those local connections so that we have networks. Right now we have plans, but we haven't got to full integrated networks of walking, bicycling, and transit that would make it feasible for most people to use those. The implementation phase and the next steps as part of this project, of course, we went out and did a little bit of a roadshow to talk with stakeholders about what we found and discuss this project. And that was particularly relevant in light of the new administration. And at this point, the infrastructure bill was more of an idea, and now, of course, it's been actually advanced. But figuring out how do we advance this project, how do we promote the local network to make sure that it can be successful. We recommend some additional follow-up research to really rerun those forecasts of potential ridership, to better include non-work trips and to figure out what the ideal service schedule would be. We worked with Jefferson Parish to talk about, how can we get that station area plan off the ground. Same with the airport is another area where currently there's just not a lot of activity happening, but we're really starting to see those conversations emerge now. And we know that state leadership is definitely amenable to seeking federal opportunities for funding in the proposed infrastructure plan back in the spring and summer. This link was on the map in the published documents, which is an encouraging sign. And then, of course, we also wanted to talk about where are the other barriers and opportunities. At the time, this corridor was in the process of changing ownership, as somebody else bought it, and now there's a merger happening, which created the opportunity to really get into the weeds about what are the logistics of making this happen. And one thing that emerged from these conversations was the idea that, the rail line is already in place, it's just not quite set up for passenger service yet. So maybe what we need are some pilot and demonstration trips to really start to make it feel real to people, and potentially special event service as a way to slow roll the introduction of passenger rail. And there's another missing piece on this one. Let's see. There it is. Okay, so then the new news added just yesterday. There were a flurry of news articles saying that the Canadian Pacific that is merging right now has committed, in quotes, to provide this passenger service. And they're saying that even without capacity expansions, although some speed and safety improvements are still needed, that they are committed to the idea of at least one round trip per day for now. So that is really encouraging. That's much more than we've had previously from freight partners to really commit to this concept and to say, this is a thing that we are willing to help make happen. We know we have the governor's support talking about not just this corridor, but the corridor from New Orleans along the Gulf Coast, as well as even a new potential link up in North Louisiana. And so we would like to see some of the work that we did in this study potentially be replicated and shared in other areas that are looking at similar concepts. But of course, there's still plenty of concerns. Looking at our survey results, I have questions about who a one round trip per day, who would that really be able to serve relative to what the demands of the residents of this region look like. But it's a very encouraging start and something that we hope to see build. And I'm happy to have been able to be engaged in this conversation during this period. So I think that's it, and we will take questions at the end following the last presentation.
Okay, perfect. Thank you very much, Ms. Colford and Dr. Tian. That was excellent. We really appreciate it. Okay, let me share the... Now I will introduce our last presenter, Dr. Eric Dumbo. Dr. Dumbo is the Associate Director of the Collaborative Sciences Center for Road Safety and Associate Director of the Journal of American Planning Association. His work spans the domain of urban transportation, including planning, policy, engineering, and design. Dr. Dumbo has directed 3 million in externally supported research activities and has received the profession's premier scholarly accolades, including Best Paper Awards from Transportation Research Board of the National Academies of Science and the Journal of the American Planning Association, among others. Dr. Dumbo, I will turn it over to you.
Yeah, thanks. Let me pull this up here real quick. And I'm going to try to be brief. So, all right, really quick. What prompted this study is we sort of have this narrative around rail transit, right? That rail transit is going to be a panacea for safety. So this is something apt to put out, right? And it's, if we just invest in rail, our safety problems will be improved, right? People will drive less, walk more, there'll be reduced BMT, reduced exposure. And so all of these different threads of activity should lead to a reduction in crashes and injuries. Now, most of my work has been with street design. And one of the things I found in digging through the basis for many of our engineering practices is the engineering logic we use to do the designs that we put into place aren't supported by the evidence that we have. And I wondered, I see these things and I wonder about it. So and you guys will have seen this in the news, down here in South Florida, we have one of the first privately operated new rail systems in the country, the first one in 100 years. It's called Brightline. So they wanted to operate this thing on existing rail tracks, and they did. Technically, it's privately funded, really the state's underwriting it, but an interesting thing happened. Once they started operating service on this corridor, this wound up being the most dangerous train line in the United States, right? It kills about one person every 3 weeks, right? And it's, you can see these here, it's in the news constantly. People are getting plowed over by this thing. And the game we play, right, is we blame the victim, right? We say, well, the pedestrian wasn't doing what he or she should have been doing, right? The driver wasn't doing what they should have been doing. They were distracted. They were playing on their phone, right? And so we try to address safety through a PR campaign, right? And these PR campaigns are largely based on ignorance and an attempt to avoid accountability, right? And that's exactly what you see with Brightline. It's killing people, and it's, well, we could either put in infrastructure that will improve this, or we're going to hire some people at minimum wage to stand out in front of the stations for a couple of weeks until them stay off train tracks, right? And they also, just to go back, Brightline likes to sell this as, oh, these are people committing suicide, except the bulk of the people getting killed are in cars, right? So it's, what, are people getting near a Brightline train? And they're like, I don't like my life anymore. Being near this thing makes me unhappy. I'm going to pull out into the intersection and die in this train and kill my loved ones with me. Or is there something fundamentally wrong here, right? And you go into the research, and there's no shortage of opinions on what we ought to be doing, but the data don't really explain what's going on with the safety effects of these things. So I dug through Bureau of Transportation statistics, and I was surprised at what I found. That, buses are a lot safer than cars, heavy rail's a lot safer than cars, light rail systems that operate at grade have twice the fatality rate per passenger mile traveled as passenger cars, right? There's not a lot of mileage of travel that goes on this, but you're twice as likely to die as a result. Now, this is also going to greatly underestimate risk, because the only thing we're counting with this are passengers in that vehicle. Those trains hit other people. Even worse, those trains change, particularly when they're at grade, change the operation of intersections. So it's not just trains hitting people that's a safety problem. The potential problem is the change in operations can cause two vehicles to collide at that intersection, can cause vehicle to collide with pedestrians and cyclists and the like. Those risks are entirely unaccounted for. So when I was looking at what was going on with Brightline, it really led me to wonder what's going on with these systems. There's a lot of discussion about, let's use existing freight rail tracks in urban areas, because that'll reduce the capital cost of new construction. And while that's fine as an idea, we don't really know what the safety impacts of that are. And what we see with Brightline is that it can be quite bad. So what we did is we wanted to look at two systems that did similar to what Brightline did. One's passenger rail, one's light rail, both of them operating on existing tracks. The safety test you want is not opinion, it's a before-after study. What were crashes like beforehand? What were crashes like afterwards? And what's the difference? All right, so that's what we did. And we combined that with audits, safety audits of high crash locations to see if we can understand the nature of these crashes. All right, so the first one's Orlando Sunrail, which opened in 2014. We used 3 years of data before that to account for regression to the mean, 3 years of data afterwards to figure out how crashes might have changed both around the stations and then along the corridors themselves, right? So it's not just what's going on at the station, but when there's an at-grade intersection where the rail occurs at grade, what are the safety impacts of that? So we looked at those too. We looked at different dimensions, but I'm going to screen some of that out. The real impact for stations is that just 1/10 of a mile around it, not even a 1/4 mile. Most of those changes and crashes are occurring within 0.1 miles, right? And in the case of Sunrail, you had a more than doubling of crashes within 0.1 miles of that. Right now, we think that these are mostly rail vehicle collisions, and we went from 0 to 1 in this area. Not a big deal, even though 100% is a big percent, the numbers, one person got hit. That's not a huge safety problem, right? But what we saw when we look at other crashes is profound changes. 1 pedestrian to 4, again, not a huge deal. But I want you to pay attention to these multiple vehicle crashes. Rear end collisions up 204%. Angle collisions, which are some of our most severe collisions, up 76%, side swipes where one car bangs into another, 400%, and then fixed object collisions where somebody runs into a pole, right, 183%, right? So the safety impact is not just the train running into things. That's actually pretty infrequent. It's all these other changes that are going on around there. All right, so what about intersections? That's going to tell us a little more. Crashes, killed, severely injured went up by more than 200% at these intersections. The only difference here is the rail service going along that. So additional gate closures and additional changes in operations as a result. All right, 200% increase in total and killed and severely injured crashes. And where those align, right here, we see some more rail vehicle. We go from 2 to 17, which is high in absolute percentage terms, right? Numerically, not so much. But the big ones, rear end. This is where one person's driving, collides into the rear end of another car in front of them. That goes up. I can't see my slide quite on this. Let me move this. I'm looking at myself, which is far less interesting than what I'm trying to present to you guys. All right. Statistically significant, right? So these are the significant differences. Rear end collisions and angle collisions. And that angle collision should be a real cause for concern. All right. So where are rear end collisions happening? We did our audit. Most of them concentrate at 4 locations. And interestingly, they all have the same characteristics, right? This is where one car rear ends into another. Fortunately, these tend not to be severe. Where we have these problems is when we have rail tracks located more than 200 feet from the intersection. And the reason that's the case is once you hit 200 feet, the manual for uniform traffic control devices doesn't require you to coordinate the gate closures with the adjacent signal. Now, the driver's progressing through the corridor is paying attention to the signal, not the gate closure sign, right? If that green ball is coming up on the light, you approach it at full speed, they're not prepared to stop. The first vehicle stops when the gates come down, the other person's just automating the driving task, right? They're not expecting the person in front of them to stop, boom, rear end collision, right? So this is an issue that very likely we could resolve by simply expanding the intersection area of influence. When there are rail tracks located adjacent to a signalized intersection, go beyond 200 feet, right? It might be 300, we need to do a sensitivity analysis, right? But where there's little expectancy for a gate closure, but a gate closure exists, you need to coordinate those signals so that the signal that the lead driver is paying attention to is providing advance notice for what's about to happen, all right? Yeah, that's the MU2C, won't go into that. Angle collisions also had a consistent pattern, right? This is when you had a 4-way intersection and then the rail tracks located along one of the things. So what we've now done is we've created a more complex intersection with rails coming through part way. And so what that means is you've got on these intersections here, particularly on the left turn, vehicles will pull out into the intersection, look to queue, right? They're not going to get that clearance. The gate comes down, you pull out, you get into the angle intersection. Likewise, there are going to be sight distance issues that occur here that'll cause that to happen, right? But a clear pattern for where these angle collisions are a problem. It's this specific configuration, right? And the solution to that is, we don't like to do this for operations, but it's protected only left turn. Get rid of that permitted left turn. MUTCD allows you to keep, they say we recommend you consider it, but lets you keep that permitted left turn. And when you do your operational analyses, that permitted left turn is always going to look good. It's always going to outperform the protected left turn. So there's a real reluctance to just require people to stop at the stop bar before they make that left. But if you want to address the safety issue, that's the solution to that problem. Rail vehicle, I won't get into that for time. All right, Charlotte Links was a little more problematic because the before data was no good. So we changed our model, right? The before data for Orlando was good. We used Charlotte simply to confirm, see if we could confirm what we were seeing for Orlando, right? So we had to dump the before period data. But if the things we're seeing in Orlando are the case, it should also be reflected in the after period for Charlotte. All right, so that's what we did. And in fact, that's what we see, the same kind of problems here. Rear end collisions, angle collisions are the big ones, right? The rail vehicle, not a particularly big problem here. It's rear end and angle collisions. So it's multiple vehicle collisions near an intersection, all right? Same thing here. And when we look at where these, almost all of these for lengths occurred at 4 locations, right? And it's exactly the same configuration we saw before. We've got the rail tracks located adjacent to an intersecting street. All of the crashes are occurring here, right? So this problem is in particular, and it's compounded by something we do when we put these things in. Sunrail did it, and both of these systems do it. When you've got freight lines, you tend to have a single track, and then the trains are able to pass by something known as a passing loop, which we see here. So one train pulls off to the side, the other passes, and it comes out. Now, for operational purposes, if you've got passenger rail, passenger transit occurring on here, you don't want that passing loop because it stops the opposite direction of traffic. So what's done in all cases is we double track, right? So instead of the single track that causes the closure, you've now got a second track. That expands that intersection area of influence there, right? So it makes it more difficult for the crossing vehicle to get through it. So that's the issue going on with a lot of these things, right? So just to wrap this up real quick, the issue here, even though we think about rail vehicle collisions, it's not that. It's multiple vehicle collisions. PEDs go up and bikes go up too, but it's really multiple vehicles that are the problem, and we don't address these well at all, right? The things we need to look at: manual for uniform traffic control devices, policies on traffic signal preemption, right? When you've got the crossings, the use of left turns, right? Right now, there's a little too much discretion permitted in here, and we look at what people are doing. These mistakes are getting people injured and killed. So I will, and with that, I think I might have left you guys, my friend, to 3 minutes for questions.
Thanks a lot, Dr. Dumbo. That was excellent. Okay, so this concludes the presentation portion of our webinar. Now we will start receiving questions from the attendees.
Yeah, one more question is, you mentioned doing a sensitivity analysis for the distance of the rail and the intersections. How is that done?
So what we'd need to do to get that is we'd have to look at, you need a pretty large sample of intersections, right? Of different lengths or distances between the rail and the intersection. We capped ours at 250 feet, so we didn't get anything beyond that. But it was interesting that the real high crash locations were all in that 50 feet. So it would be worth expanding that margin out 300, 350. So we start capturing those rail lines. And at some point, you're going to see a tapering off, right? At some point, you would expect that what's going on in that intersection is no longer going to be meaningfully related to what's going on the rail crossing. Now, when we do intersection analyses, and the reason we weren't even expecting to find this, the reason we use 250 feet is because when you do an intersection safety analysis, that's what we call the intersection area of influence, right? And I didn't even know this going into that the MUTCD only uses 200 feet for rail crossings, and it assumes anything beyond that isn't going to have an influence on that intersection. And in fact, they need to be coordinated. They need to be controlled. So the sensitivity analysis would require looking at intersections further up and seeing, based on crashes, where there's a tapering off.
I have a question for Eric.
Mhm.
This is Samir Ahmed. I just disagree with you, Eric, on a number of things. First of all, you try to present engineers or show them as they kill people. That's not correct. When your topic had to do with operating transit, light rail transit on shared right-of-way, okay? The right-of-way was originally designed for commuter rail, for example. And then you are operating light rail on it. The key thing in here is the frequency, okay? When you operate commuter rail, people in the vicinity, they expect 1 or 2 trains, 3 trains at the most per day. Now,
Right.
you are operating a light rail, and the light rail vehicle arrives every 30 minutes.
Sometimes
Okay.
more frequently.
Well, whatever, but the point is, it's the frequency now of, that's not an engineering problem. That's the agency was forced. You either want light rail or not. If you want light rail, they said, well, I'm going to use this existing track. So that's a problem. I don't agree with it. But from an engineering point of view, but education, which you try to discount, And understanding behavior, which again you try to discount, is very critical. If you don't tell people about what to do around the tracks, just regardless of what engineers can do, it is not good. Whether it's the manual or uniform traffic control devices, whether it's permitted, whether it's left turn, whether it's protected left turn, just they have their own behavior, okay? And they violate rules. Lots of pedestrians cross a typical intersection against the vehicles, although they are saying don't walk. So it's in my opinion, engineering treatments are critical. In your presentation specifically, you should have mentioned clearly that it's the frequency of service that's creating the problem. And number three,
I agree with that.
Yeah, I'm just trying to. I'm trying to defend the engineering profession.
Well, and again, I've got a PhD in engineering, and I would debate that operations is not an engineering issue. And certainly, I spent a lot more times on operations than I did on engineering design. But I'll let you continue.
Okay, I think that's all. So education is critical to improve safety. Engineering treatments can always be improved, but there is a limit as to what engineers can do. Okay, especially if you don't have land. If you don't have land to build a light rail, just you either have to use an existing rail used by other carriers or don't have light rail at all.
Well,
thank you.
When you look at corridors that are successful, and I'm thinking of the Northeast corridor in particular, what they do is they close the corridor, right? So you're not going to have these at-grade crossings. So it's not the case that we can't engineer a solution. It is the case that we're not willing to pay for that solution in money. We'd rather pay for it than lives lost. So that's how we go about it. You could seal the corridor. It would be expensive. You would have to move that grade up or down, right? And that's a lot of money. And I understand why folks wouldn't want to do it, but we shouldn't pretend that it's not a choice that we're making, because it is.
Maybe a follow-up question for both Dr. Ahmed and Dr. Dumba here is that, so say you're building a train from New Orleans to Baton Rouge, and it's going to be an infrequent train on existing tracks with a fair number of at-grade crossings, but not a ton. What are your sort of top recommendations that the planners and folks applying for federal grants to consider this should be looking out for optimizing safety and avoiding Florida headlines?
Intersection control.
I agree. You just have to, again, try to have gates that can be lower than, which in many intersections you don't have them. Try to have active devices. Plus, again, I go back to education. Education can be done at schools. The residents that are nearby, people who work nearby, you have to make them aware of the risk involved. So when they try to go out and come near the location, they are aware that there is risk.
Thank you.
Okay, do we have any other questions?
I read a question that was addressed to me, but I haven't heard it yet.
Yeah, there's a question in the chat addressed to Dr. Ahmed saying, how is train driver alertness taking into consideration for VURs?
Yeah, this question has to do with the operator of the light rail vehicle. There's blame, of course, that they carry. Some of them are inattentive, and we have seen that in the news a number of times. Some of them are careless. But if you recall, the objectives of that first presentation was to develop material that can be used to educate not only users, but also transit agency employees. That includes the operator of the light rail vehicle. Educating them and making sure that they are aware of the importance of being attentive, having cameras that record what they are doing when they are operating the train. All these are things that can be done. So education, again, and the training for the agency employees will help improve that.
Okay. Again, I think with this, we're going to end. Again, I would like to thank our 4 presenters for their time and technical presentations. Or
do we have time for one more question?
Oh, yeah, of course.
Yeah, I have a question for Eric. When you're looking at these intersections, do you have a database of characteristics for the intersections? such as distance from the rail, turning characteristics, or this is sort of like more manual, like you look at each intersection and then piece together the patterns?
Yeah, so the way we did this was sort of a safety audit. So it's not ideal in that a lot of the data that we need, we don't have. We don't have good operational data. We did a lot of this during the pandemic, so we weren't even traveling for the field work, right? So it's doing essentially road safety audit practices, which is let's analyze the patterns here that we have and figure out what those likely factors are. But the point is that I want to make is not that I've got a conclusion to this, but rather these are the specific issues and the specific locations that we need to know a lot more about, because these are where the problems are, right? So the safety audit's intended to help, and I'm assuming you're a researcher, I hope so, to give people direction on what kind of things should we be looking at, because there's a body of research we really need and we don't currently have.
Yeah, I imagine part of that is just like that network characteristics. What is at these intersections? What are the characteristics and the operations, like you say?
Yeah, absolutely, absolutely.
Okay. Do we have any other questions, or? I think we're good. Well, I would like to thank our 4 presenters for their time and technical presentations. I want to thank also the attendees. Please let me know if you have any questions about the webinar series and about Tran-SET. Otherwise, have a great rest of your day. Thank you.
Thank you all. I enjoyed it.
Thanks,
Thank you.
everyone.
Bye.
Great presentations.